You're lost, not the kind of lost where you glance at your phone and a blue dot tells you exactly where you stand. Genuinely lost. It's 40,000 years ago, somewhere in what's now Central Australia, and in every direction there's nothing but flat, dry ground stretching to the horizon. No roads, no signs, no landmarks worth nomming. Walk the wrong way and you die, not eventually, soon. There's one water source within a day's walk. Miss it, and the next one is 4 days further, and nobody survives 4 days without water in that heat. But you're not panicking, because inside your head is something no other animal on Earth has ever built. A map, not drawn on paper, not carved into stone, a map made of songs, stories, and memory so exact that you can cross 1,000 kilometers of open desert just by singing the right verses in the right order. That map is older than writing, older than cities, older than farming, quite possibly older than language itself. So how did that happen? How did a primate that started out navigating the same way every other animal does, just remembering where the food was, end up building something powerful enough to literally redraw the surface of the planet? The answer starts inside your brain, long before humans ever existed. In 1971, a neuroscientist named John O'Keefe at University College London was recording electrical activity in a rat's hippocampus when he noticed something odd. Certain neurons fired only when the rat was in one specific location, not triggered by a smell, not by a sight, just by being in that exact spot. He named them place cells. He discovered that the brain doesn't experience space the way you experience a photograph. It builds an actual map, constantly updating, tracking where you are, where you've been, and how everything relates to everything else. 34 years later, two Norwegian researchers, May-Britt Moser and Edvard Moser, found the next piece of the puzzle. Working at the Norwegian University of Science and Technology, they discovered neurons in the entorhinal cortex that fire in a near-perfect hexagonal grid as an animal moves through space. They called them grid cells. If place cells are the pins on your mental map, grid cells are the coordinate grid underneath them. Together, this gives your brain something no engineer has ever matched. A self-updating, three-dimensional model of the world, running with no batteries, no satellites, and no code. In 2014, all three shared the Nobel Prize for what the committee called the brain's inner GPS. And this system isn't unique to us. Rats have it, birds have it, bees likely have some version of it too. Back in 1948, psychologist Edward Tolman had already shown that rats build what he called cognitive maps, flexible internal models of space that let them find shortcuts they've never physically taken. Nearly every animal that moves through space carries some version of this hardware. What makes humans different is that at some point we did something no other species has ever managed. We took the map out of our heads and put it somewhere else. Think about what that actually takes. You have to compress three-dimensional space, something you move through with your whole body, into a flat image someone else can read. You have to decide what's worth keeping and what isn't. You have to agree on symbols. This direction is north, this shape means water, that mark is a mountain. You're translating lived experience into abstraction. That leap from experiencing space to representing it is one of the biggest cognitive jumps our species ever made. And once a map exists on a surface, it can be shared, taught, handed to someone who's never set foot where you have and still get them there. So when did we first do this? Honestly, we don't know, because the earliest maps were almost certainly scratched into dirt or sand or simply described out loud, and none of that survives. But the oldest physical objects that might qualify are much older than most people assume. In 1962, archaeologist Bohuslav Klima was digging at a site called Pavlov in the Czech Republic when he uncovered a mammoth tusk fragment, roughly 25,000 years old, covered in engraved lines, wavy marks, arcs, circles. Klima read it as a topographic sketch of the local landscape, the bends of a nearby river, the slope of nearby hills, maybe even a settlement. 25,000 years old, made during the depths of the last ice age, and someone may have been mapping their world. Or maybe not. That's the constant problem with prehistoric maps. You're looking at marks on a surface and trying to guess whether they represent the real world or something else entirely. A similar argument surrounds a wall painting at Saddlehuryuk, a Neolithic site in Turkey dating to around 6200 BC. When archaeologist James Mellart excavated it in the 1960s, he called it the oldest map in the world, an aerial view of the settlement with a twin-peaked volcano erupting behind it. Decades later, in 2006, researcher Stephanie Meese argued that what Mellart saw as a volcano was actually a leopard skin pattern, a common decorative motif at the site, and that there was no map at all. Researchers still disagree. And that disagreement makes an important point. A map is only a map if someone can actually read it as one. Strip away the cultural context and it's just lines. One candidate, though, has much broader agreement. In 1993, archaeologist Pilar Utrilla and her team at the University of Zaragoza found an engraved stone in a Abans cave in northern Spain, roughly 13,660 years old. Utrilla spent 15 years studying it before publishing in 2009. The engraving appears to show a mountain, rivers, ponds, and possible travel routes, and it lines up with the actual terrain surrounding the cave. Someone studied the land around their home and scratched a simplified version onto rock, likely to plan a hunt or explain a route to someone else. Nearly 14,000 years ago, no writing, no cities, no farming, and already someone was making maps. From here, the story of maps splits into two completely different paths that wouldn't reconnect for thousands of years. In some parts of the world, people figured out how to put maps onto physical surfaces, clay, papyrus, stone. In other parts, they built something arguably even more impressive, maps that lived entirely in memory, carried through song. The Aboriginal peoples of Australia developed what are now known as songlines, or dreaming tracks, navigational systems woven into songs, stories, and ceremony, describing the landscape in such precise detail that someone who has never visited a place can navigate it just by singing the verses in order. Landmarks, water sources, rock formations, seasonal food sources, all embedded directly into the lyrics. The land itself becomes a memory device, where each feature cues the next part of the song. Astrophysicist Ray Norris has shown that some songlines even encode star positions for navigation, and researcher Lynn Kelly has compared the whole system to the ancient Greek method of loci, calling it one of the most sophisticated memory systems humans have ever built. These songlines are estimated to be at least 10,000 years old. Some researchers argue they could stretch back 60,000 years, to the earliest human presence on the continent. If true, that would make them not just the oldest maps on Earth, but one of the oldest continuous intellectual traditions our species has ever produced. On the opposite side of the world, the Marshallese people of Micronesia built something entirely different but every bit as remarkable: stick charts. Frameworks of coconut fiber and root, tied together with shells marking island positions and curved sticks representing ocean swell patterns, how waves bent around islands, reflected off underwater ridges and interfered with one another in predictable ways. These weren't carried on the water. They were study tools learned on land before setting sail, training navigators to physically feel the ocean's hidden structure through the hull of their canoe. The Polynesian navigators who settled the vast stretch of ocean from Hawaii to New Zealand to Easter Island pushed the idea even further. No compass, no instruments of any kind. Instead, a memorized mental map of roughly 220 stars and where each one rose and set throughout the year. A navigator would steer toward a star as it climbed the eastern sky, then shift to the next rising star once the first climbed too high to be useful. When clouds blocked the sky, they read the ocean itself. The rhythm of deep swells felt through the canoe's hull. Bird flight patterns told them how close land was. Cloud color told them what lay beneath. A faint green tint often meant a shallow lagoon. Training took decades, starting in childhood, passed down entirely through chant and song, never through anything written. In 1976, a voyaging canoe called the Ho Macron Ku Macron Le letter 2BB sailed roughly 4,000 kilometers from Hawaii to Tahiti using nothing but traditional wayfinding. The navigator Maupiailug, one of the last living master navigators from Satowal in Micronesia, guided the canoe with no instruments at all, just stars, waves, and birds, and arrived within sight of Tahiti. That voyage proved the old oral traditions were telling the truth. The Pacific really was settled by people reading the ocean like a map. Consider what all of this, songlines, stick charts, star compasses, actually tells you about the invention of the map. None of it looks like what most people picture when they hear the word. No paper, no grid lines, no compass rose, but all of it is a map in every sense that matters, spatial information encoded in a form that can be taught and shared, letting someone navigate ground they've never personally walked. The technology isn't the paper. It's the idea that the shape of the world can be compressed down into something that fits inside a human mind or a human hand. The physical maps most people actually picture start showing up in Mesopotamia, in what's now Iraq. The oldest surviving object that nearly everyone agrees is a genuine map is a small clay tablet about the size of your palm, found at a site once called Gosur, later Nuzi. It dates to around 2300 BC during the Akkadian Empire and shows hills, rivers, and a marked plot of land, a property record with a picture attached. It now sits at Harvard's Semitic Museum. And it says something easy to overlook about why maps were invented in the first place, not for exploration but for ownership. The moment you draw a line showing where your land ends and someone else's begins, you've created a legal claim, a boundary. The map stops merely describing the world and starts deciding who owns pieces of it, a connection between maps and power that would only get stronger over the next 4,000 years. Mesopotamia also produced the oldest known attempt to map the entire world. A small clay tablet inscribed in cuneiform, now known as the Babylonian Imago Mundi, dating to roughly the 6th century BC, possibly copied from something several centuries older. It shows the world as a flat disk, Babylon at the center, split by the Euphrates, ringed by an ocean the Babylonians called the Bitter River. Beyond that ring, 8 triangular regions point outward, representing distant mythological lands full of strange creatures and legendary travelers. It's not a practical navigation tool, you couldn't use it to find anything. It's a statement about the universe. This is where we are, this is how everything is arranged, and we are at the middle of it. Every civilization that has ever drawn a world map has put itself at the center. The Babylonians simply did it first. The Egyptians pushed the idea towards something more practical. Around 1150 BC, a scribe named Amenhotep created what's now called the Turin Papyrus map, the oldest known geological map, commissioned by Pharaoh Ramesses IV to plan an expedition into the eastern desert. It shows roads, hills, gold mines, and quarries color-coded by rock type. It's not symbolic at all, it's a working document, closer to a modern geological survey than anything a civilization 3,000 years old should have been capable of producing. But it was the Greeks who tried something nobody had attempted before, mapping the entire known world. Around 550 BC, the philosopher Anaximander of Miletus is credited with one of the first attempts, a circular map showing Europe, Asia, and Africa ringed by ocean. No copy survives, but the underlying idea that the whole planet could be represented on a single surface was genuinely new. About 3 centuries later, the librarian Eratosthenes, working at the Library of Alexandria, did something remarkable. He calculated the Earth's circumference. His method was elegant. He knew that at noon on the summer solstice, the sun sat directly overhead in the city of Seen, casting no shadow at all. In Alexandria, roughly 800 kilometers north, a vertical pole cast a shadow at about 7.2 degrees off vertical, 1/50th of a full circle. Multiply the distance between the two cities by 50 and you land within about 2% of Earth's actual circumference. 22 centuries ago, with nothing but a stick and a shadow. Later, around 150 AD, Claudius Ptolemy wrote a work called Geographia that would shape mapmaking for the next 1,400 years, assigning coordinates to roughly 8,000 locations and developing methods for projecting a curved planet onto a flat page. His system had a real flaw, though his estimate of Earth's size was about 30% too small. That single error would help convince a Genoese sailor named Christopher Columbus, more than 1,000 years later, that he could reach Asia by crossing a much smaller ocean than the one actually in his way. Independently in China, a Jin dynasty official named Pei Xiu was developing cartography on his own terms. Around 267 AD, he laid out 6 core principles: scale, orientation, distance, elevation, angle, and correction for curved versus straight paths, that any modern cartographer would recognize instantly. He built this with zero exposure to Greek geography. Different continent, different language, same underlying problem, same solution independently reached. Maps like the boat or the bow seem to be an invention that different cultures kept arriving at on their own. In 1136 AD, Chinese cartographers carved a map known as the Yujai Tu onto stone, using a strict grid where each square represented about 50 kilometers. The coastline it depicts is accurate enough that you could lay it over a modern satellite image and recognize the shape, roughly 8 centuries before European mapmaking reached anything close to that precision. Which raises an obvious question. Why does most popular history treat Europe as the origin of mapmaking when it clearly wasn't? For most of history, European maps weren't the best in the world. Often they weren't even close. Medieval mappamundi were theological documents, not navigational ones. The Hereford Mappamundi, made around 1300 AD, places Jerusalem at the center, scatters biblical scenes across the page, and fills the margins with mythical creatures. It's beautiful, it's historically fascinating, it would be functionally useless for actually getting anywhere. Meanwhile, in 1154 AD, the Arab geographer Al-Idrisi completed the Tabula Rogeriana for King Roger II of Sicily, one of the most accurate maps of Eurasia and North Africa produced up to that point, blending Greek mathematical geography with contemporary Islamic scholarship and first-hand traveler accounts, engraved onto a silver disc. While European maps were still populating Africa with dragons, Al-Idrisi was mapping its actual coastline. There was one European map style that genuinely worked, though, the Portolan chart. These appeared in the Mediterranean around the late 1200s, made by and for sailors, showing coastlines with striking accuracy, covered in networks of straight-bearing lines radiating out from compass roses. A navigator could lay a straight edge between 2 ports and read off a heading directly. Nobody fully knows how these charts first came together. They appear in the historical record already fully formed, with no obvious predecessor, and their accuracy has puzzled scholars for decades. The likeliest explanation is that they grew out of generations of accumulated written sailing directions, bearings, and distances between ports that someone eventually translated into geometry. The reason most people default to a European-centered history of maps isn't that Europe got there first or best, it's that European maps eventually became the maps that reshaped the rest of the world through conquest. That's a story about power more than accuracy. In 1507, German cartographer Martin Waldseemüller did something no map had ever done. He put a name on the newly encountered landmass across the Atlantic. America named for Amerigo Vespucci, not Columbus. One word on one map and an entire continent carried that name permanently afterward. That's how much power a map can hold. It doesn't just describe the world, it names it, and in naming it decides what officially exists. In 1569, Flemish cartographer Gerardus Mercator published a projection that solved a real problem for sailors. On his map, a straight line represented a constant compass bearing, letting navigators plot a course without constant correction. Genuinely useful. But the projection came with a distortion that quietly reshaped how people picture the planet. Landmasses inflate in size the further they sit from the equator. On a Mercator map, Greenland, about 2.17 million square kilometers, looks roughly the same size as Africa, which is actually 14 times larger. For 450 years, the world's most used map has been making Europe and North America look bigger than they are, and Africa and South America look smaller. Not a conspiracy, just the underlying math. But the effect on how people imagine the world's proportions has been very real. Then maps stopped being art and became engineering. In the 1740s, French astronomer César-François Cassini de Thury began the first systematic national land survey ever attempted. Using triangulation, pick 2 points, measure the distance precisely, then calculate a third point's position using geometry and keep expanding the network outward. His surveyors planted markers across the entire country and took thousands of astronomical readings, eventually producing over 180 map sheets. 4 generations of the Cassini family worked on it, spanning nearly 70 years, with the final sheets not published until 1815. Gave France the first geometrically accurate picture of its own borders, famously prompting King Louis XVI to complain that the survey had cost him more territory than any war, because older maps had simply drawn France larger than it actually was. That same map later became a tool of the French Revolution, used to redraw the country into new administrative departments, a map commissioned by royal astronomers ending up as an instrument for dismantling the monarchy that paid for it. And for perhaps the starkest example of a map reshaping reality directly, in 1884, representatives from 14 European nations met in Berlin to divide up Africa among themselves. They drew straight lines and geometric borders, often following rivers chosen simply because they were visible on a map from thousands of kilometers away, not because they made any sense on the ground. Ethnic groups were split apart by lines drawn in a room none of them were in. Those borders, drawn by men who had never set foot in the places they were dividing, largely remain the borders of Africa today. A map made in a Berlin conference room in 1884, still shaping who lives in which country nearly a century and a half later. And then maps left the surface of the Earth entirely. On October 4, 1957, the Soviet Union launched Sputnik. At the Johns Hopkins Applied Physics Laboratory, physicists William Geer and George Weifenbach noticed that the satellite's radio signal shifted frequency as it passed overhead, higher approaching, lower receding, the Doppler effect, and realized they could use that shift to calculate the satellite's orbit. Then someone flipped the question: if you know the satellite's position, could you use the same shift to calculate your own position on the ground? You could. The U.S. Navy built the first satellite navigation system to help submarines find their location without surfacing. By 1973, the Department of Defense had begun work on GPS, launching its first experimental satellite in 1978. By the 1990s, a full constellation of 24 satellites, each broadcasting a precise time signal, let a receiver on the ground calculate its position within a few meters. Around the same time, a classified CIA program called Corona was putting cameras into orbit, photographing the Earth and ejecting the film in capsules that parachuted back down to be caught midair by specialized aircraft. Over 12 years, it photographed the entire Soviet Union in enough detail to count individual aircraft on runways. When it was declassified in 1995, its archive of over 800,000 images became a resource for archaeologists and climate scientists alike. For the first time, maps were being made by machines that had actually seen the whole planet from above. And here's where the story comes back around to where it started: the brain. In 2020, researchers Louisa Damani and Veronique Bobat at McGill University published a study on what happens to the brain when navigation gets outsourced to GPS. They found that heavy GPS use is linked to reduced gray matter in the hippocampus, the exact region where John O'Keefe found place cells firing back in 1971. When you navigate using your own spatial memory, you're actively engaging and maintaining that internal map. Follow turn-by-turn directions instead, and you bypass it almost entirely, relying on a more automatic, habit-driven part of the brain. People who lean on GPS most tend to show smaller hippocampal volume and weaker spatial memory over time. Think about what that actually means. For at least 13,000 years, maybe 60,000, humans have been building, refining, and passing down maps, pushing the brain's spatial capabilities about as far as they can go. Aboriginal Australians encoded entire landscapes into memory through song. Polynesian navigators crossed thousands of kilometers of open ocean by reading waves. Greek scholars calculated the size of the planet with a stick and a shadow. And now, within a single generation, we're handing all of it over to a device in our pocket. The map traveled from inside our heads onto clay, onto paper, onto a screen, and now the screen may slowly be replacing the map inside our heads again. So how did humans actually invent maps? Here's the answer. They weren't a single invention. The same idea got invented over and over on every continent by people with no knowledge of each other. Every single time one condition was met, a human brain needed to get spatial information into another human brain that wasn't there to see it firsthand. That's the whole engine behind it. Every map ever made, from a 25,000-year-old mammoth tusk to the map tile loading on your phone right now, exists because someone needed to say the water is over there to someone who couldn't see it for themselves. Songlines, stick charts, clay tablets, portolan charts, satellite imagery, all of it is the same basic impulse. Take what I know about where things are and hand it to you in a form you can actually use. The underlying biological capacity for spatial mapping almost certainly evolved once in Africa and traveled everywhere along with migrating humans. But the act of putting that capacity onto a physical surface that was invented again and again, independently in Mesopotamia, in China, in Australia, in Micronesia, in Egypt, in Greece, in the Americas, no single culture invented the map. It kept inventing itself everywhere because a brain built to construct internal maps was always eventually going to find some way to show that map to somebody else. Tonight somewhere someone will open an app, type in an address, and watch a blue line trace a route, without ever thinking about the 60,000-year chain of human effort behind that line. And somewhere else, an elder will sing a song describing a river they've never personally seen, teaching a child to find water in the desert through nothing but a memorized melody. Running on the exact same hippocampal machinery John O'Keefe found firing inside a rat's brain in a London lab in 1971. The technology keeps changing. The underlying idea hasn't. Someone knows where the water is, and they're still finding a way to tell you.